Ladies and gentlemen, a greeting to all participants of the conference. Let me present to you the work on the topic Intelligent System of Dynamic 2D Visualization of Passenger Flows of Public Transfer Routes based on OpenGL. The international teams of our work, Matseliukh, Berko, Kowalska-Styczeń, and Chyrun, united scientists from Ukraine and Poland, namely from Lviv Polytechnic National University, Lviv Ivano-Franko National University of Lviv, and Silesian University of Technology. This problem was investigated for the first time since 2017 for adopting a management decision in the transport industry. From a different point of view, this problem was highlighted at an international conference. The self-piloted buses were considered within the limits of small city. Further topics develop occur in the next track, which is presented there. First of all, it is necessary to specify what is important. The basic of passenger flows is a passenger who moves in time and space, and the grouped flow of passenger form a passenger flows. As the number of passengers increase, so do the requirements for the quality of public transportation. The relevance of the topic lies in need of establishing an interaction between the factor criteria by which the quality of passenger transportation is assessed. The vague aim of improving the interactiveness of public transport for city resident due to the increase of the quality of passenger transportation through passenger flow management. The object of the study is the process of 2D visualization of passenger flow on public transport routes. The subject of the study is the method of the principles of 2D visualization and forecasting of the passenger flows on the city routes. The Python programming language was chosen as a tool for the solving given problem. A large number of libraries, etc. models should be noted as the main advantage. Other benefits are listed in the table on the slide. And among the existing shortcomings, there were none significant from the point of view of the implementation of this project. The interface model and graphical data visualization model are the most important models used in our project. Among the interface models, the choice was made between the capabilities of the arcade part of the international model and TkinCat. As a result, the arcade was chosen, the characteristics of which are better. A large amount of the graphical data visualization model, the choice was made between Pygame and arcade. As a result, the arcade was chosen because it supports OpenGL for drawing primitives for 2D rendering and has the appropriate set of the capability table on the slide. As a result, the SQLite database was chosen for the use in this designed system. The slide shows a database diagram in which GTFS data is stored. This project uses the database as contained defined mandatory tables, and the GTFS standard approves this set. This project also uses neural networks to predict passenger flows on the route when the vehicle schedules change. The example of the structure of the neural network is given on the slide. The following data are submitted to the input of the neural network, namely time of arrival at the stop, departure time from the stop, stop number, transport unit number, and the exit. We get the volume of the new passenger traffic. This project on this slide shows the main interface of the software product. To select a route, click on the Get Route button and select the desired of the from one list of the route that will appear. View of the interface after successfully selection a route. The mode on the map button will start working on the mode on the map. The schematic mode button will start working in schematic mode. After training the neural network, the visualization schematic button will be displayed the result. View on the map mode is shown on this slide, and the features of this mode are: first, movement on vehicle in both directions; second, the arrival of transport at a stop, dropping off and picking up passengers; 3. Change in rendering speed, which is displayed as service information in the HUDI in the lower right corner; fourth, change of scale of the maps and route, which is displayed as service information in HUDI in the lower right corner; fifth, a vehicle that is at the final stop. The schematic mode view is shown on this slide, and the features of this mode are: the selecting stop and running between stop with all relevant information displayed, scrolling along the entity routes line. Schematic mode allows you to display the main indicator in the route on the form of graphs. Graphs are built by clicking on the corresponding blocks. This slide provides information about the stop. On this slide, information about the overrun between stops is given in the form of graph. Schematic mode is used to display the result of the neural network, which predicts passenger flows on the route when the vehicle schedule is changing. An example of this mapping is shown on this slide. So, at all available and no scientific development and literature source for solving the problem of 2D visualization of passenger flows is cities are analyzed. It was established that the visualization of passenger flow is one of the most important tasks for improving of quality of passenger transportation by public transport. The expediency of choosing the Python programming language with the main models Arcade, GeoPy, Matplot, Multiprocess, OpenPyGF, PyGTF, and TensorFlow for 2D visualization passenger flow is substantiated. With the help of OpenGL, low-level communication with the rendering of graphic elements was provided, developed by unique one-oven algorithm for creating visualization in two modes, schematically and on the map, placed on the stop on the route. A software product has been created for 2D visualization of passenger flows based on real conditions and to predict change in passenger traffic according to the new schedule on the vehicle using a neural network. Thank you for your attention.